Hello everyone, and welcome to today's presentation. I'm excited to guide you through the process of finding zeros of a quadratic equation by factorization. The title of our session is Finding Zeros of a Quadratic Equation by Factorization, and the subtitle is Step-by-Step Guide with Examples. Over the next few slides, we'll explore how to approach these problems systematically, with clear examples to help you understand each step. Let's get started. So, what are zeros? In essence, zeros are the x-values where the function equals 0. Think of them as the points where the graph of the function touches or crosses the x-axis. For example, if you have a quadratic function like y equals x squared plus bx plus c, the zeros are precisely the points where the parabola cuts through the x-axis. These zeros are also often called roots or solutions, because solving for zeros is like solving the equation for when y equals 0. Recognizing these zeros helps us understand where the function has specific values, especially 0, which can tell us a lot about the behavior of the graph. Throughout this presentation, we'll see how finding these zeros is crucial for graphing functions accurately and understanding their key features. They're fundamental to analyzing the shape and intersections of quadratic functions, so keeping track of zeros is an essential skill in algebra. So, why do we focus on factorization? Well, it helps us break down a quadratic expression into two simpler parts, making it much easier to work with. When we factor, we can then apply the zero product property, which is a really powerful tool. It tells us that if the product of two expressions equals 0, then at least one of those expressions must be 0. This allows us to solve quadratic equations more straightforwardly. Factorization is especially efficient when the quadratic is easily factorizable, meaning it can be broken down neatly into factors. Overall, understanding this process is key because it simplifies solving quadratic equations and connects directly to the fundamental principles we'll be exploring today. All right, let's start with step 1, standard form. When working with quadratic equations, the goal is to write them in the form x2 plus bx plus c equals 0. This means all the terms need to be on one side of the equation, and the other side should be 0. For example, if you have an expression like x2 5x plus 6, you want to set it equal to 0, so it becomes x2 5x plus 6 equals 0. This standard form is really important because it's the foundation for other methods of solving quadratics, like factoring, completing the square, or using the quadratic formula. Remember, ensuring everything is on one side and 0 on the other helps us clearly see the coefficients and constants, making the next steps much easier. All right, now let's move on to step 2. Multiplying a times c first, it's important to identify the values of a b and c in the quadratic equation. Once we know these, we focus on multiplying m and c together. This step is crucial because it helps us understand the relationship between the coefficients and the overall structure of the quadratic. For example, if we have a equals 1, b equals 5, and c equals 6, then multiplying m and c gives us 6. This product will be useful later when we factor or analyze the quadratic equation. Remember, this step lays the foundation for simplifying and solving quadratic expressions effectively. Now let's move on to step 3, find two numbers. The goal here is to identify two numbers that will help us factor the quadratic. These numbers need to meet two criteria. Their product must equal a times c, and their sum must equal b. For example, if the product is 6 and the sum is minus 5, then the two numbers we're looking for are minus 2 and. Notice how minus 2 times gives us 6, and minus 2 plus gives us. Finding these two numbers is a crucial step because it allows us to break down the middle term and factor the quadratic more easily. This step connects directly to our overall theme of simplifying and solving quadratic equations efficiently. Now, let's move on to step 4, split middle term. This is where we get to see the power of factoring in action. The key idea here is to replace the middle term, which in our example is minus 2x, with two terms whose coefficients add up to the original middle coefficient, but whose product is the same as the product of the first and last coefficients. So in our example, we have x2 minus 2x minus 3x plus 6 equals 0. Notice how we split the middle term, minus 2x, into two parts that will help us factor by grouping. The goal is to find two numbers that multiply to give us the product of the quadratic coefficient and the constant term, which is 1 times 6, or 6, and add up to the middle coefficient, which is. Once we find those two numbers, we replace the middle term with two terms using those numbers. This makes it easier to factor by grouping, as you'll see. Remember, this step is crucial because it transforms a quadratic that might seem complicated into something more manageable for factoring. So, always look for those two numbers first, and then apply this splitting method to simplify your quadratic expression. Now, let's move on to step 5, group terms. The key idea here is to group the first two terms together and the last two terms together. For example, if we have the expression x2 2x, 3x 6, we want to see these as two separate groups. This approach helps us see the structure more clearly, making it easier to factor or simplify. Remember, grouping is a powerful technique because it often reveals common factors or patterns that weren't obvious at first glance. So, when you're working through an expression, try to identify logical groupings, usually pairs of terms, that can be factored or manipulated together. This step is all about organizing the expression to make the next moves smoother and more straightforward. All right, now we're at step 6, factor each group. This is where the real magic happens in factoring quadratics. The key idea here is to look at the expression and identify common factors within each group of terms. Once you find those common factors, you can factor them out, which simplifies the expression significantly. For example, consider the expression times x minus 2 minus 3 times x minus 2. Notice that both terms share the same binomial factor, x minus 2. By factoring out this common binomial, we get x minus 2 multiplied by the sum of x, and which makes the expression much easier to solve. The most important concept here is to recognize the common factors in each group, because that allows us to rewrite the expression in a simpler form. This step is crucial in the overall process of solving quadratics through factoring, as it sets us up for the final step of solving for x. Remember, identifying and factoring out the common factors within each group is the key to unlocking the solution efficiently. All right, now we're moving on to step 7, factor common binomial. This step involves identifying and factoring out the common binomial from two or more terms. Essentially, what we're doing is looking for a binomial that appears in each part of the expression and then factoring it out. For example, if we have x2, x3 equal to 0, we notice that both factors are binomials. While in this specific example, the binomials are different, the key idea is that when they are the same, we can factor them out. This process simplifies the equation and makes solving much easier, especially when we're dealing with quadratic expressions or higher-degree polynomials. Remember, the goal here is to identify the common binomial, factor it out, and then set the remaining factors equal to 0 to find the solutions. This step is crucial because it helps us break down more complex expressions into manageable parts, bringing us closer to solving the equation efficiently. Now, let's move on to step 8, where we apply the zero product property. This is a really important concept when solving equations that involve multiplication. The key idea here is that if the product of two factors, p and q, equals 0, then at least one of those factors must be 0. In other words, if p times q equals 0, then p has to be 0, or q has to be 0. This helps us break down more complex equations into simpler parts that are easier to solve. For example, imagine we have the equation x minus 2 equals 0, or x minus 3 equals 0. When we see these, we understand that either x minus 2 is 0, or x minus 3 is 0. This is the core idea behind applying the zero product property. It allows us to set each factor equal to 0 separately, and then solve for the variable. This step is crucial because it simplifies the process of solving equations, especially when we're working with factored forms. Remember, the most important concept here is that 0 times anything is 0, and if the product is 0, then at least one of those factors must be 0. This principle helps us find solutions efficiently and connects directly to the overall theme of solving equations by factoring. Now let's move on to step 9. Solving for x. From our previous work, we found that x equals 2 and x equals 3. These are what we call the zeros of the quadratic. Essentially, they are the points where the graph crosses the x-axis. Identifying these zeros is crucial because they tell us important information about the quadratic's roots and its behavior. Remember, finding the zeros helps us understand where the parabola touches or crosses the x-axis, which is often a key part of solving quadratic equations or analyzing their graphs. So, in this step, we've pinpointed the solutions, and those solutions are x equals 2 and x equals 3. All right, let's take a moment to do a quick visual recap. Here, we have the graph of the quadratic function y equals x squared minus 5x plus 6. What's important to notice is where this parabola intersects the x-axis. These points happen at x equals 2 and x equals 3. These intersection points are what we call the zeros of the function. Remember, zeros are the x values where the output of the function is 0, meaning the graph crosses the x-axis. Recognizing these points helps us understand where the function changes sign and is really useful in solving equations or analyzing graphs. This ties back to the overall theme of understanding key features of functions through their graphs. Let's take a look at a practice question now. We need to find the zeros of the quadratic equation x2 plus 6 equals 0 using factorization. Remember, the goal here is to determine the values of that make the equation true. That's what we mean by zeros. To do this efficiently, I want you to try applying the 9-step method we discussed earlier. This method guides us through the process systematically, helping us stay organized and confident. Start by identifying the coefficients, then look for two numbers that multiply to the constant term, minus 6, and add up to the middle coefficient, 1. Those numbers will help us factor the quadratic. As you work through the steps, keep in mind that the key to factorization is breaking down the quadratic into two binomials. Once factored, setting each binomial equal to 0 gives us the solutions, our zeros. This practice not only reinforces our understanding of the method, but also demonstrates how factorization connects directly to finding solutions to quadratic equations. So, give it a try, and remember to follow each step carefully. All right, let's walk through the answer to our practice question. We started with the quadratic equation where a equals 1, b equals 1, and c equals minus 6. When we look at the coefficients, we notice that a times c gives us minus 6, which is an important part of factoring. Next, we need to find two numbers that multiply to minus 6 and add up to the middle coefficient, which is 1. Those numbers are 3 and minus 2. These are the key to breaking down our quadratic into factors. So the factors of the quadratic are x plus 3 and x minus 2. Setting each factor equal to 0 gives us the solutions, or zeros, of the equation. That means equals and x equals 2. These zeros are crucial because they tell us where our graph crosses the x-axis, connecting back to the overall theme of understanding how factored quadratics reveal the solutions visually. This process really highlights how factoring simplifies solving quadratic equations and helps us interpret their roots clearly.